Good morning, Tahmina Khan is here in TKMaths S1. In today's video, which is video number 3 on the explanation of Poisson distribution, which is the part of the syllabus of A-level mathematics S2. In the earlier two videos, we have covered these three concepts. The link you will find in the description below. And as I have explained you earlier, I'm just taking one solved example or two solved example to explain these concepts, because it is a quick recap of the topic Poisson distribution. For the more complex challenging question which I have explained and taken from past paper, you will find the link in the description below and on my blog address. So let's continue with the third video on the topic Poisson distribution as an approximation to the binomial distribution. But before that, I will go through the concept of ln in Poisson distribution. So for that, you need to recall that if e power x is given to you and you have to find out x, definitely there will be something. So you take ln on both sides. When you take ln on both sides, then you apply power law and it's become x ln e. Whatever is here will also have ln that number. We will see in the example 6 here. I'm just helping you to recall it. And ln e is equals to 1. And this is how you get the value, right? So if e power x is equals to 0.315 and you have to find the value of x, then what will you do? You will simply take ln on both sides, right? And ln 0.315 is equals to minus 1.15518. And we give answer in 3 significant figure. So let's see the example here. The random variable x is distributed by this, which is a very clear indication that it is a Poisson distribution, and your lambda is what? 0.3n. Find probability of x greater than equals to 5 when n equals to 4. Part 1. Let's do part 1 first. On the left hand side, there is part 1. So first of all, you will write down the Poisson distribution, the way it is written. And then after that, you have to find the probability of x greater than equals to 1. And I have explained to you earlier, whenever it is greater than equals to, in Poisson distribution, we always do 1 minus what is not included. So if you see here, what is not included? You are starting from 1, 2, 3, 4. So 0 is not included. So 1 minus probability of x equals to 0. And we know the formula for calculating the probability of Poisson distribution, e power minus lambda power x over x factorial. So we have applied this formula to get this. And n is given to you 4 in the question. So you will plug in the value of n and simply apply the calculator, nothing else. So part A is very simple. Now part 2, find the least integer value of n so that probability of x greater than equals to 1 is greater than 0.95. So this whole line is written in the maths form here. You can see here, right? So now, what does this mean? Probability of x greater than equals to 1 is same as this line, right? So this is what we will write here. Okay. After that, we are rearranging. Here, in part 1, the value of n was given, but in part 2, we have to find the least value of n. So we are rearranging it. So it can be rearranged in 2 ways. Let's see first of all what it is written here, if you can understand. It is simple algebra. The left hand side is taken to right hand side and right hand side to left hand side. Then you are subtracting. Now you will take ln on both sides, right? Once you will take ln on both sides. By the way, if you see switching in equation, switching is different, but in inequalities, the sign changes, right? I hope you know this is all prerequisite knowledge. So now you are taking ln on both sides. Excuse me. Now, here is a common mistake made. Now let me tell you what is that mistake. You can pick up the calculator to understand what I'm saying. What actually happens is students do what? ln 0.05 divided by minus 0.03, and they write this thing as it is. N is less than, let me tell you what do they do. 0.5 divided by minus 0.03. Now what happened, this answer is also negative, numerator, and this is also negative. So automatically it becomes a positive answer. And they do not change the sign. Whereas whenever we divide by a negative number, we change the inequality sign, right? Don't forget that. So once you will change that sign, then what you will get? N is, let me see the answer. I don't have a calculator here. So N is greater than 9.985. But what was question saying? Question was saying, find the least integer value. So if it is 9.985, then what is the least integer value? Is it 9 or 10? It is 10, right? Because this answer you want, 9.985. So the next integer value is 10. So if you want to check, though you don't need to, so you can check it here by substituting the value. But this is not required, okay? So now let's go to the topic which we have to do, the Poisson distribution as an approximation to the binomial distribution. So the question will be given to you in binomial distribution, and from S1, the distribution of binomial is what? NP, that, right? Which is given here. And the distribution of Poisson is what? Distribution of Poisson has lambda, and lambda equals to mean. So how do you calculate the mean in binomial? Do you remember? Yes, it is equals to NP, right? So you will calculate NP and you will get the mean, which is also equals to variance in case of Poisson, right? But once you are writing it here, it will be your NP, which will be written here. So this is how you will change, but in which case you will apply? The question comes, in which case I will apply Poisson distribution as an approximation to the binomial? There is certain condition which I have to see. Do you remember what is that condition? Whenever you are solving, you have to show through working that the condition satisfy, and that's why I can apply it. Number one is n should be greater than 50. So in binomial question, the n should be greater than 50 and your NP should be less than 5. These two conditions you must have to check. If this is satisfying, then you can apply Poisson approximation for binomial question, right? Okay, and we have already seen that my NP will be my mean, okay? So you can note down this condition, which is must, and you have to show this in the checking. When conditions say justify that why you can apply Poisson distribution, then you have to show this, okay? And please remember this thing, larger the value of n and smaller the value of p, the more approximate answer it will be. Approximate to what? If you had actually applied binomial, then it will be same as Poisson. Okay, now let's see one example and then we will finish this video. This is a past paper question. I don't remember which year it was. 1.5% of the population of the UK can be classified as very tall. Okay, 1.5%, right? And part 1, the random variable x denotes the number of people in the sample of n people, so n is not known, who are classified as very tall, and the mean is given to you 2.55. You have to calculate n. So now, if you know in binomial, the distribution is NP and mean is NP, right? So NP equals to 2.55. Let's see here. First of all, you will write distribution. Then you will tell what is P and what is NP, mean. So your NP mean, and this is equals to 2.25, which is given to you in the question. It will help you to form an equation and you can calculate n. Right? I hope there is no problem. It was a simple question. By using the Poisson distribution as an approximation. Now this is the requirement of the question. So you can't say, oh, why don't we use binomial? Because question is saying use approximation. And sample size is 210. And you have to calculate the probability fewer than 3. It means you will calculate the probability for x less than 3. This is your question. And your n is 210. Okay. So because it is the same question, so your p will be 1.5%. Okay. And you know 1.5% is 0.015. So now, first of all, you will show in the question that condition is met. What was the condition? N is greater than 50 and NP is less than 5. So you will show this in the question that this condition is met, and that's why I can apply Poisson approximation, right? So you will write all these steps. So you have seen NP is 3.15, which is less than 5. See here, NP is less than equals to 3.15, which is less than 5. And N is 210, which is greater than 50. So it means condition is met once you have shown. So you will write, okay, since it is justifying, so you can apply Poisson approximation and show the lambda for it, which is NP. You can see here, right? Now because you have to calculate the probability of x less than 3, which means 0, 1 and 2, simply apply the Poisson formula and get the probability. So this is how you will use Poisson approximation. Writing each and every step is very important. So thank you very much. If you have any query, you can write in the comment. And for the more past paper question, you need to visit my blog address or the links given in the description. Please share with your friends and take subscription and like.